Now we have the third presentation in category 2 from Mrs. Shikha Kumari from Narbhiram Hansraj English School, Jamshedpur. Yes, just a minute. To introduce the participant and share with us a few lines about the school, we have Mrs. Parmita Rao Chaudhary, the head of the institution. Ma'am, Paramita ma'am, I hope you are able to.
Am I audible? Am I
Yes,
audible?
Yes, you are audible.
Yeah, I am Tandrima Banerjee. As Parvita Rajwadiri, our principal ma'am, is not present right now. I'm the Chief of Administration, Narviram Hansraj English School. First of all, I want to thank Tata ClassEdge for organizing such an encouraging platform for the teachers. We are happy about teacher Shikha, who has been selected for this event. She is associated with teaching learning process for 8 years. It is her dedication and hard work towards the field of education are commendable. I wish her good luck for today's event. Thank you so much.
Thank you so much, ma'am.
Over to Shikha.
Yeah, thank you, ma'am. Thank you so much for the introduction. Yes. Shikha, ma'am,
yes, sir.
I'm
Yes.
sharing screens that is slides that you have shared with us. Just a moment.
Dignified judges, respected principals, and all the participants, a warm good afternoon to everyone present over here. I'm Shikha Kumari from Narviram Hansraj English School. I'm going to represent the topic diffusion of Standard 8 Chemistry. And my learning outcomes are, the first one, after this class, students can experience learning which increase their deeper understanding of the concept. Students can apply the theoretical knowledge to practical situation inside and outside of the classroom. They can relate these things with the practical life. I want to achieve these. And the third one is students can establish the relation between temperature and nature of matter with rate of diffusion. So shall I start now?
Thank you, Shikha, ma'am. Yes, may we have the classroom view, please?
वो ब्राउनी मूवमेंट बदल लगा बदल नहीं लगा ठीक है ना आप देखिए बदल मजा मैं आ जाऊं.
Yes, ma'am, can you hear me?
Yes, sir. I
Okay.
can hear you.
So, yeah. Okay, so I'm also able to hear you. Ma'am, your time starts now. Please start once the buzzer is audible. Yes, may we have the buzzer for Shikha, ma'am?
Good morning, everyone. How are you all? Okay, so we will start today with a small activity. Okay, so first of all of you close your eyes. Close your eyes. Close your eyes. Okay, I am having a room freshener. You identify its fragrance. Okay. Identify the fragrance. Which flavor it is? Say. Yes. Yes, it's lily. Very good. Now wait for a minute. I have another one more room freshener. Now you identify this one, and this one is my favorite. Okay. So identify this one. This one, say which because. Wow, very good. You all are very smart. Now you can open your eyes, please. So what happened now? I just sprayed this room freshener and you immediately I will give you an answer which fragrance it is, which flavor it is. So what is the reason behind it? What might be the reason behind it? Yes? Yes, say?
When the particles of the fragrance mixes with the particles of the air, making us perceive its fragrance.
Yes, very good. Here, what is happening? When I just split it out, the air particle that but you have read already, the air particles are constantly in random motion, isn't it? And this spray is also a gas. It is also again in random motion, and they are just mixed into each other. Isn't it? This happened. So here he said, this student said, these particles got intermixed. So they got mixed on their own, isn't it? So this is called diffusion. What do we call it? Diffusion. So today we will study about the topic diffusion. So what is diffusion? As we have told just now, the mixing of particles on their own from higher concentration to lower concentration. The mixing of particles on their own from higher concentration to lower concentration is called diffusion. Now let us see on video.
An extent that the dominating motion exists. Take two jars, one filled with oxygen and the other nitrogen dioxide. Now invert the jar with science over the jar with oxygen. Observe the downward motion of both the gases. After some time, the random movement of gases intermix. This is evident from the appearance of jars. This process of intermixing of gases to form a uniform mixture without any force is called diffusion.
Here, we have not mixed these things. In the one jar, there was oxygen gas. In another one, there was nitrogen dioxide gas. And what is the color of NO2 gas, nitrogen dioxide gas? Brown. And when we mixed it, all this one become brown color. These gases get diffuse on their own, they get mixed on their own. So this is diffusion. Okay, see one more video.
Particles of all gases do not move at the same speed. Let us perform an experiment to understand this. A solution, hydrochloric acid, 2 droppers, a long glass tube, and 2 cotton plugs. Close both the ends of the glass tube with the 2 cotton plugs. Using a dropper, simultaneously add hydrochloric acid and the solution drop by drop from either side of the tube. Instantly, it sits on the other tube and hydrogen fluoride start moving towards each other. The 2 gases react with each other to form a white ring of hydrogen fluoride. However, the white ring does not form the center of the tube as expected. Another gas being lighter than hydrogen fluoride gas travels faster. In other words, the diffusion of ammonia gas is quicker than that of hydrogen fluoride gas. Thus, it is established that particles of all gases do not move at the same speed.
So here what we have done, this tube we have taken and we have added 2 bottles. Dip one just with the ammonia and second with the hydrochloric acid HCl. And what happened? Say these gases diffuse, they diffuse and they make ammonium chloride. They react, ammonia reacts with hydrochloric acid and it forms ammonium chloride. So we get a white ring over here. And since this one is heavier, ammonia is heavier. And as HCl is not so heavy, it's just because sorry, for mistake. HCl is heavier than ammonia, so it moves faster. Ammonia molecules move faster, and we get ring not in between, just here. Okay, so now let's see one activity I am going to see you, and then you will tell me what are the factors on which diffusion depends. Okay, see children, here I have taken three beakers. Okay, in the first one there is a hot water I have taken. In second one I have taken normal water, and in third one I have taken cold chilled water. Okay, now I am going to add ink. Good children, come. You add one drop of ink in each. Add, come, yes. Add one drop of ink in all these. Yes. Now just observe this and you will answer my questions. Okay, in which one diffusion is very fast? Right? Yes, yes, say loudly. It's hot water. Yes, in hot water you can see clearly. Actually almost the diffusion has been done. Okay. In this warm, normal water, it is taking little time, and in the cold water, it will take more time to get diffused. So, what may be the reason for this? For this, yes, yes, Raksha say.
Ma'am, the molecules of hot water are having more kinetic energy than the molecules of cold water and normal water.
Yes, yes, very good.
So they mix quickly with the molecules of air.
Yes, very good. So, what is happening here? In case of hot water, the particles, the molecules of water are there wrong rapid constant motion. Their kinetic energy is very high. So, they are moving very fast. Okay, so they get mixed very fast. And in case of normal water, kinetic energy is medium in compared to cold water. In this case, kinetic energy is very less. So the first we have covered the factors of diffusion. The first factor is temperature. The first factor is temperature. Just you have seen in this activity. Higher is the temperature. Yes, eh? More is the faster is the rate of diffusion. Isn't it? Is it clear to you all? Okay. Now the second thing. What is the another factor on which diffusion rate depends? Okay. Now see one thing. I'm going to show you. Now see, this got diffused. Okay, and these are taking more time than others. Isn't it? Okay. Now see, now again I will take two beakers full of normal water. These are normal water. Okay, these are not hot or cold. And now I am going to add, in the first one I am going to add, let's say you come and add, this is food color. Okay, add a pinch of food color in this. First one, pinch, take a pinch of, so it will also come. Yes, add a drop of this honey in the second one. Now observe this activity. Yes, be quick. Yes, now observe this. These two beakers. In which one diffusion is faster? In which one diffusion is faster? Say. Yes, in food color. In case of food color, what is happening in the first case? These food color particles are very small. Particles are not very small, so they get mixed easily. And in case of honey is denser, denser. It has more viscosity, so it takes more time to get diffused. Okay. What is second factor, beta? Second factor is the nature of solid. The second factor is nature of solid. So these are the factors on which diffusion depends. Okay. Now let me tell you what is diffusion you define in your own words. Yes. Sorry.
And the balancing of the gaseous molecules on a higher concentration fluids
Lower concentration. Yes, very good. And what are the factors on which diffusion depends? Yes. Yes, temperature and the nature of the solid. Okay. One more thing is here that I will tell you during the question answer session. So, okay, this is done. Now, there is a question for you. Arrange solid, liquid, and gases. Okay, listen the question carefully. Arrange solid, liquid, and gases in increasing order of rate of diffusion. Arrange solid, liquid. Can you hear me properly? Yes. Arrange solid, liquid, and gases in increasing order of diffusion. Yes. Increasing order means this one they are more
solid.
so in the case of solid, We call it legacy diffusion sometimes. What? In solids also things get diffused. How? I'm giving you an example. Like if you write in the board, and just I have given you for summer holiday homework. Suppose I have given you holiday homework. Okay. And I have written, and after a month you will be back. Yes. Then if you want to rub the board, it will not get rubbed easily because the upper surface of the board, this chalk particles has been absorbed by the upper surface. Okay, so these are the things. So the order should be solid, then liquid, then gas. Okay, is it clear for you all? So I'm giving you one homework. I said before that, one more thing I want to ask. Give some real life examples of diffusion. Yes. Burning of incense is very good. When it will puja also, we have the big candle, isn't it? So after some time we get a nice fragrance of that incense sticks. Another example, yes. Yes, very good. Whenever your mother cooks food for you, something delicious, your favorite food like pulao, biryani, anything that you like the most, immediately you tell your mother is cooking very delicious food, and you rush to the kitchen, isn't it? So these are the real life examples. You can for more real life examples of this. Okay. So your homework is to make a poster on real life examples of this. Okay. Okay, class. Thank you.
Ma'am,
Yeah. Yes, sir.
we can't see you.
Yes, sir.
Stop now.
So now I'm audible and visible. Yes.
Yes, you are audible and visible. Yeah. You still had 2 more minutes to complete it. So just wait. Yeah, thank you, ma'am. Thank you so much for the presentation. Yes. Now I would request Dr. Ebenezer and Shalini ma'am if you have any questions for Shikha ma'am.
Shikha ma'am, thank you so much for your presentation. I would have appreciated the last question that the last statement that you made had it come in the beginning. When your mom cooks some biryani or something, you smell and you go inside, you should have begun with that. Or imagine a teacher wears a nice perfume and comes and you say, ma'am, you're smelling so good. You could have started from there, right?
Yes,
It would have been better because always remember learning is from concrete to abstract, from known to unknown. And ma'am, one small suggestion, so not suggestion, rather correction. The definition that you wrote on the board has a fundamental error. It is not particles, ma'am, it is molecules. And it is not mixing, it is movement. They need not mix. The molecules need not mix, but they move. The movement of
sir, I can say something, please. Sir, particles include in lower classes from the beginning. Particles include atoms as well as molecules.
ma'am,
It includes.
Is your school a CBSE school?
Sir, ICSC.
ICSE or CBSE, the textbook reads that, movement of particles with respect to molecules or atoms is mentioned. Atoms are unstable, molecules are stable. So when we are fundamentally talking about diffusion, we talk in terms of molecules and not in terms of atoms or radicals.
Yes,
Point number one. So please mention that it is movement of molecules from a higher concentration to lower concentration, and fundamental thing that you missed is till an equilibrium is attained. That is very important.
Yes, sir.
That
Yes, sir.
part is
Equilibrium also
missing.
attains. Yes.
That is very important, ma'am. Okay, conceptually, that was something which I wanted to tell you. And another thing that you could have added is all this happens without the intervention of energy.
Yes, sir. Without
Okay,
mixing.
this is not an
Without
this is not
energy,
an endothermic process. This is not an endothermic process. Okay, you may not use the term endothermic, but you say it doesn't require any temperature. But temperature does increase when you're talking about, when you talk about temperature as one of the fundamental factors for, rate of change of diffusion. When you're talking about rate of change of diffusion, then you talk in terms of dependencies called the temperature, right? But if it naturally happens, then it is called diffusion. And if it is happening, it is actually you're increasing, or rather you're adding a catalyst called temperature. Temperature is your catalyst, which is increasing the rate of your diffusion. Correct?
Yes,
So
sir.
when you give the example of hot water where you added a drop of ink and the color got mixed easily. And I would have appreciated, ma'am, if you would have used some examples, real life examples of diffusion. See, you were talking about diffusion in liquids, but diffusion does happen in solids and liquids and gases. The best example for liquids, solids is agarbatti or camphor for that matter, camphor. Aarti dete वक्त हम camphor also you could have used. Solid, liquid to perfume is the best example. And the third one, that is any smell for gas, any smell. It could be something being cooked at home or the smoke that emits out of the exhaust of vehicles or any pungent smell that is there from the garbage. So and one more thing you have to tell is saturation is very important. When you say equilibrium, that's very important for diffusion.
Yes, sir.
Equilibrium is attained. We cannot see diffusion happening for our own self. When we spray perfume, we'll smell that perfume. After some time, others can smell our perfume, we cannot, because already our body has attained that equilibrium. So that part should be there. And I'm glad that you used tools of assessment, and also you gave them some recapitulation and follow-up work to make a chart. I appreciate that. But I thought these things you should have addressed, ma'am.
Yes,
So
sir.
please take.
Sure, sir. Next time. Yes, sir.
Thank you so much.
Thank you, Dr. Abhinay.
Yeah, so Shikha,
Yes, ma'am.
your entry into the class with the spray and everything was very nice. It actually brought in, the concept what you're planning to take. And also you very beautifully switched from the blackboard to the smartboard. But instead of wasting time in writing the definition, I would, I would like if you could, use the definition which is already there in the board, so that the children can, see that. It would save you time, because since it's already there, the data
Yes,
class
ma'am.
very beautiful model of that also. And then in the end, you give arrange your solid, liquid, gas in increasing order of diffusion. That question could be little more, on a higher order thinking.
Yes. That can.
It's not something which could perceive. I mean, the children already have perceived it in the beginning, so that had no value when you give it in the end. So maybe you have some clarity on that. And when you write your lesson, most of the things Mr. Ebenezer has already discussed with you. But I would come back to the learning outcome, because when you look at the learning outcome, see, you have to now, for example, if you want to test your outcome or second outcome, students can apply theoretical knowledge to practical situation inside and outside of the classroom. If that is your outcome, how will you evaluate that?
Ma'am, whatever they are learning, I want they should apply in their real life and for future purposes also.
No, because
So in this case,
yeah, very specific in
yes,
your
yes.
lesson plan, yeah.
Yes. In this case, like early in the morning when we wake up, our room we just open our doors and windows to get the fresh air. So that can be applicable like this.
Okay, but how will you assess? How will you evaluate whether all the children have understood that, or you want to assess it? Okay, you can think about it. No
Yes,
issue.
ma'am.
Then the third one is students can establish relation between temperature and nature of matter with the rate of diffusion. So this temperature and nature of matter,
Yes.
in the first one you have written experience learning with deeper understanding. So you've given them an experience with something that came in the smart board. You gave a simulation kind of a thing, and then you also brought a spray in the room. But how do you establish relation between temperature and nature of matter? I think that also.
For temperature, ma'am, I have shown the hot water, normal water, and cold water. So in the hot water, ink get diffused very faster than the cold and normal water. So this is the dependency. they can relate temperature and rate of diffusion. More is the temperature, the higher will be the diffusion rate. And in case of the nature of solute, like I have used honey and food color. So honey, since honey is more viscous, so it take more time to get diffused, like as compared to this food color. So by this,
And pressure, I'm sorry, ma'am. Pressure is also another factor you could have discussed. Pressure.
yes, sir. Actually, this is a standard 8 also, so we have to bind ourselves with some limitations. That is.
I think the bigger you expose them to bigger concepts, but dilute that to that class level. I think that is where the teacher achieves. The teacher becomes, you have a very beautiful class. You expect whatever you want to, throw across to the children. I think they achieve the target.
Yes, yes, ma'am.
Anyway, it was good.
Thank you, ma'am.
Thank you, Shalini ma'am. Right. Thank you, Shika ma'am. Thank you, sir. Thank you, Ebenezer sir. Right. So now